Good morning, guys. Geez, I have feel like I've been really tired recently. It's probably shows in some of the videos. And last night finally had a nice evening out without the kids for once. Honestly, an absolute rarity. Anyway, it is day 2 of the stainless steel build. Sorry, we're machining recessed light tops. It's only me in today, so I have to run back and forth between the two to get it done. It's really bloody noisy. It's only the drill cycle and the part-off cycles that's really noisy on it, but the rest of it's not too bad. Anyway, yeah, so we've got the lights on test behind the camera. They've done their underwater test already, and they're now doing a burn-in. Normally we do the underwater test and the burn-in at the same time, but because we're working with like new tops and whatnot, we need to make sure that every time that we're passing the water test, because I don't want to start ruining LEDs when we're not, you know, absolutely 100% sure when things have been changed. Anyway, yes. So I'm going to use we use black hinges for stainless steel spikes and stainless steel wall lights if we're doing full stainless, because we haven't quite managed to crack the hinge in solid stainless steel. We kind of did it once-ish, but we really struggled to tap it. Really struggled. We did on the Haas machine, what we did is what's called a peck tap, where it like rolls in, rolls out, like, and does basically like millimetre increments at a time. And literally the machine is like at 200% torque. It struggles, it really does, and the tap kept turning around in the holder. So yeah, it's something that I'll look at in the future and try and see if I can resolve, but it's a difficult one really. Maybe if I make the hole a little bit bigger, that will fix it. So assembly of this particular this hinge, etc. We got our rod. Oh, let me glove up. We've got our 316 stainless steel rod, and we have a insert, which is the insert that pushes the spring up, and also gives us a smooth exit and entry point for the cable, because it's plastic. It's machined on the Haas machine. So basically, that insert goes in, the rod screws in. Now this is where it gets embarrassing because it doesn't screw it on camera. Of course it doesn't. It might be just because I had it in the sleeve, possibly, or it might be that there's paint in the thread, which happens occasionally, not very often. I reckon 1 in 100 hinges. I mean, it's pretty well when we powder coat these. Oh look, the thread's fine. It's just me being an idiot. But yeah, they're pretty well covered to stop it from happening. Then we have what we call the T insert, which is just a hole with a little step in it, and our spring. The spring goes over like that, and this just pops straight in the top. Easy. Now I've got a spike here that unfortunately has got some thermal paste on it. I'll just quickly show you how that goes together. So the cable runs, I have to put a little bend in it, cable goes through and comes out of this little slot here. And the idea of this design is that, that hopefully you won't see the cable, because my understanding is that if you were to spike this in the ground, you would spike the spike all the way down. Of course not everyone does, but but that's the idea, or at least our idea. Yeah, so if you did that, you'd only see that coming out the ground, and then the cable exits very low, rather than seeing a cable trace all the way around. So you basically push this down and turn it. He says, God, yeah, it'll go. Or it'll snap. We've had it. a couple of ball joints have we've had a couple that have gone. It's basically because we're using normally what happens is when we have aluminium rods, they have a hole through to hang for powder coating, and that's perfect for sticking an Allen key through and then basically grabbing that and twisting the whole thing. It makes it a lot easier. I'm gonna have to take my gloves off. I've kind of got no choice really. The cotton gloves are way too slippery, but I just got to hope I don't cut myself. It's tight. It's not meant to be this tight, and it might be because the some of the, again, plastics have been an issue on the machine, and some of the inserts are a little bit taller than they should be, and therefore because it's taller the spring is just being absolutely compressed to the max. You know, there's only so far that can go. There we go. Done. Right, we're in. So there you go. That's the spike there, and then all we do is we basically loop this up. I'm going to laser mark the cable. Now I won't bother showing you guys laser marking on a cable. You've seen plenty of laser stuff, but I'll laser mark the cable. First I tie it up and I just leave a little end off like this, and I basically lay that down and we do a laser mark. So we used to use a heat shrink label. Now the heat shrink labels were obviously plastic. We kept running out of them. That was one thing. I'm very like, if something's kind of unnecessary, then I will remove it, i.e. unnecessary plastics. I really don't like that. I don't like, you know, like waste on the environment, etc. But obviously we did need to mark the cable to sort of say, you know, look, this is 350 milliamp only, red is positive, black is negative, that kind of thing. Yeah, so what we decided to do is give lasering a go, and it worked really well. And so, you know, at least then when you've got a nice laser marked cable, it doesn't require any extra material. It's burning into the sheath of the laser. And I actually, after I did it, I actually imagine that whenever you see cable in with not the impression, but whenever you see the ones with the writing on, that's likely lasered, I think. But yeah, so I've got to laser this. This needs a little bit of a clean up, especially now I've touched it. But laser this. We do now a touch test just to make sure that it's still working after it's been assembled, and then we have two 221 Wagos to go on there. So that will be that done. Moving on to the wall lights. Now the wall lights are going to be a little bit of a different beast. I'm going to use this one. Basically, the customer or the electrician wanted sleeves, or at least specified the sleeves for the customer. So what happens is we have this screwed in like this. It gives it a bit more of a substantial size, but we get to keep the head size exactly the same. So it's just like kind of an add-on. The only thing is that he said he fitted some before that we made that were black, and he said the problem is that the length of the normal hinge, which is here, there we go, the length of the normal hinge basically means that, so you can bend it directly down with that, but when you've got the sleeve on, if you look at the center line there, if I just bring this down, it's not, the center line's more like there, so the hinge needs to be longer. So we're thinking that we're gonna, when we remachine hinges, we'll make some longer sleeves, but for now what we're doing is longer sleeves, longer hinges, but for now what we're doing is we're repurposing some spike hinges which we've agreed, which is fine, you know, aesthetically it's going to have exactly the same look, etc. But basically that just screws in there, just making sure that the brass is still turning. There we go. Now, my only worry had been with these is the weight and how much, you know, like how secure it was going to be when it's left in position. So I may drill a hole in the hinge here and put a little set screw, a little grub screw in there, just to push down against the ball joint to kind of keep it in place. We'll see. If I think it's stiff enough, then I won't bother. But It depends. It's not like the Chinese hinges are, they must set them in some like massive machine that they must have. Right, now if I can get this down, he says. Well, it does, but I'm not exactly happy with that position. I don't know why it's so high. So I need to make some adjustments, I think, because I'm not completely happy with that. I want the ball joint to sit low in a little dip that we create on each of them. So if I do that, I'll get that set back in, and then we'll show you what's going on. So guys, I am at the moment hunting for the right screws and washers from a set. Well, obviously just a couple of screws and stuff that I had from ages ago. Oh look, this is the way we used to make our LED boards, on fiberglass with the protection circuit straight on the back. It's all resin filled. It's interesting, isn't it? But the advantage of that is no matter whether or not you get water inside the fitting, it's not going to damage your LED. But the disadvantage is it's a bin job when it fails. So in fact, they used to be made like that as well. Well, I say they used to be made like that. No, it was just a period of time when I was experimenting with different ways of trying to do it, and that just didn't work out. So I'm so glad that we got the CNC machine and that we were able to actually make them in a great replaceable way now. Anyway, so this hopefully is now how this goes together. He says, I feel like I've picked up one wrong screw. Oh jeez, wouldn't surprise me, would not surprise me. But let's see, hopefully this will go together all right. I was just like measuring the distances between all the screws. Nope, too far out now, would you believe? Okay. Yeah, I was measuring the distance between all the screws and trying to work out how this is best to go together. Obviously this isn't it. It's alright, we'll get it there in a minute. But yeah, you know, I mean, this is nearly done now. The spikes are finished. I've packed 9 away. That's the last one to be packed. Yeah, and it's just literally, well, that one just needs cleaning up. The rest of them have been cleaned up, as I say, and been packed away. But we're about there now, although it's frustrating because it's taken me all day to do this assembly. I mean, yes, I've been running the machine and running the 3D printers and the other bits and pieces, so there is an time element in obviously all of that, and it is kind of, it's hard when you're getting dragged from one process to the next, in terms of trying to be efficient. You literally just can't be, you know, you want to be just on the one process. But that's the problem with me being on my own. In a couple of weeks now, or a week and a half, Jamie starts full-time. Well, it's 4 days a week, but basically full-time, and he will be here on Thursdays as well in part of that, which means that there won't ever be a day here where there isn't 2 people, which is fantastic, because it's going to make all the difference in terms of what we're doing and how we're building things, because you really on your own, it's just so hard to run all the processes, as I'm sure you can imagine. I'd love to know from you guys while I'm assembling this what you would like to see in a future video. So if there's anything in particular that you want to see, I mean, I will be doing a video on our new pick and place machine that we got at some point, which you may or may not have seen, depends if you follow us on Instagram or not. But yeah, so we've got a new pick and place machine for our electronics, but that hasn't even been set up. It's literally just been chucked on the rack and that's it. We've got our injection moulding machine coming in a couple of weeks. Well, hopefully less, we'll see. So that'll be something else that I'll probably do a video on as well. But yeah, you know, if there's anything in particular, just let us know. Right, there is that one done. Apart from the hand finishing, that's basically it. So what do you think? I quite like it. I like the size of it, etc. So I think I need to just sort the brushing of it. But God, it's got some weight to it. It must weigh, I don't know, I want to say 1.5 kilos, but it might be just sort of, maybe more like a kilo. But yeah, it's pretty impressive, really. I think the only change that I would make is I'd make these screws as like long grub screws. But I mean, the advantage of having ones with heads on is they're a little bit more stable for an M3 hull. I might even consider 4 screws in future. We'll see. But yeah, let me know your thoughts.